Here's problem 818. The 1 kilogram block is released from rest at the top of a frictionless incline that makes an angle 37 degrees with the horizontal. An unknown distance down the incline from the point of release, there's a spring with K equal to 200 newtons per meter. It is observed that the mass is brought momentarily to rest after compressing this spring 0.2 meters. How far does the mass slide from the point of release until it is brought momentarily to rest? So we have an incline coming down like this, 37 degrees, and we have a spring that's going to be compressed by this block, and at that point, when it finally comes to rest, will be our lowest point in the problem. So we'll define that as being 0, and we'll start with our block above that point, and that will be our height that we wish to consider. Now if I look at this triangle, let's label that. If I look at this triangle right here, it's also a 37-degree triangle. The distance D that we're talking about down this incline, this distance, is the hypotenuse of that triangle. So H is going to equal D sine 37 degrees. Good to know. Alright, and we eventually want to find out what D is. So D is going to equal H divided by the sine 37 degrees. Alright, let's employ the one equation to rule them all. We have the kinetic energy at A plus potential energy at A plus any work done along the way equals kinetic energy at B plus potential energy at B. Here we have no kinetic energy at A because it started from rest, and no kinetic energy at B because it's going to end up at rest. We have a spring involved, so we have potential energy at A, which is gravitational, and potential energy at B, which is the spring, and there's no work done along the way, no external forces. So we simply have that mg, height at A, is equal to 1/2 k x squared. Sounds good. We know what x is, we know k, so we can figure out height of A based on this. Height of A is going to equal 1/2 kx squared divided by mg, which is going to be 0.5 times k, which was 200, times x, which is the compression of the spring, 0.2 meters squared, over the mass, which is 1, times 9.8. What is that? 0.408 meters Since D is equal to this H divided by the sine of 37 degrees, it's going to be equal to 0.408 divided by the sine of 37 degrees, and that is 0.678 meters. So the distance down the incline that we go is 0.678 meters. Answer.